Hola a todas y todos, muy buenos días. Los invitamos a apagar los teléfonos celulares para ya comenzar esta instancia. En nombre de la Facultad de Ingeniería y Ciencias de la Universidad Adolfo Ibáñez y del Center for Energy Transition, Centra UAI, les damos la más cordial bienvenida a todos quienes nos acompañan en este primer seminario de combustibles limpios en la aviación, en el que se abordará cómo la industria de la aviación se adapta a los desafíos de transición energética. Saludamos especialmente al ministro de Transportes y Telecomunicaciones, Juan Muñoz, a la experta en Sustainable Aviation Fuels e investigadora asociada de la Universidad British Columbia, Susan Van Dyck, al decano de la Facultad de Ingeniería y Ciencias UAI, Claudio Sebag, a la vicedecana de Gestión y Vinculación con el Medio de la Facultad de Ingeniería y Ciencias UAI, Bárbara Stengel, y saludamos muy especialmente a nuestro panel de expertos, compuesto por el secretario general de la Junta de Aeronáutica Civil, Martín Mackenna, el gerente de desarrollo de nuevos negocios de NAP, Yuri Sagüero, a la gerente de asuntos corporativos y sostenibilidad de Sky Airline, Mayra Kohler, y al director de asuntos corporativos y sostenibilidad de la TAM Airlines Group, Juan José Toa. Para dar inicio a esta ceremonia, se dirigirá a ustedes nuestro decano, Claudio Seba.
Muchas gracias, Irene, por dar inicio a esto. Que esto de verlos en una sala de clase tiene un toque muy especial. Yo llevo 4 meses de decano y todavía todas las cosas son nuevas y sin duda esta es una agenda también muy nueva, en la cual como Universidad Adolfo Ibáñez nos estamos involucrando, así que para qué agradecerles la presencia hoy día. Venimos a aprender muchísimo, agradecer especialmente al ministro Juan Carlos Muñoz la presencia hoy día, a todos ustedes los expertos, pero una de las cosas que he aprendido en estos par de semanas sobre esta conversación es que tenemos mucho todavía que aprender. Entonces creo que esto va a ser un espacio de aprendizaje colectivo respecto de los grandes desafíos que tenemos. Cuando venía yo, los que me conocen de más años, saben, me muevo mucho en bicicleta, y venía con mi bicicleta para acá, ahora en la mañana, y pensaba un dato que siempre me ha impactado, porque yo llevo muchos años vinculado a los temas de energéticos, climáticos, y ayer, de hecho, junto con los ministros de Ciencia, Energía, Economía y Medio Ambiente, lanzamos el Comité de Carbono Neutralidad para darle un reimpulso a una agenda que en realidad nosotros como país nos convoca y nos ha unido mucho, la agenda de acción climática, la agenda de transición energética. Y cuando uno hace el análisis individual, y ahí después los expertos me van a corregir, del juego de la calculadora CO2, y basta con un vuelo a Europa o un vuelo a Estados Unidos, para qué decir a Asia, y la cuota personal de CO2 al tiro es como 50% de ese viaje. Entonces, uno que ha estado impulsando una agenda de transición energética en materia de electrificación del transporte urbano, del transporte público, hay un mundo del transporte, y el transporte, siempre la gente se sorprende cuando uno le dice que es la principal consumo energético como sociedad. La mayoría de la gente, yo les hago, a ustedes obviamente no, pero les hago esta pregunta a mis alumnos, la gente te responde: principal consumo energético es la minería, la es el transporte, es movernos. Y nos movemos todavía hoy día principalmente basado en derivados del petróleo. De hecho, la mayor parte de la gente cree que todavía cuando uno hace encuesta de que la electricidad, por ejemplo, es casi el 60% del consumo, pero no, solo el 20%. Y todos los derivados del petróleo suman como el 60%. Entonces, el desafío que tenemos en cómo nos movemos, junto con los desafíos cómo nos calefaccionamos o ahora nos climatizamos, son desafíos fundamentales, y claramente hemos estado por 200 años como humanidad quemando cosas a tasas inimaginables, y tenemos que ser creativos porque la urgencia climática nos obliga a movilizarnos, y obviamente un espacio académico como el de nuestra universidad, donde más nosotros como lema de la Facultad de Ingeniería y Ciencias es cómo combinar ideas que sean por un lado sostenibles pero también inteligentes, o sea que sean además desde la ciencia y la tecnología, es fundamental. Y por eso que tener esta conversación sobre combustibles sostenibles para la aviación nos pareció tremendamente importante, de poder convocar actores diversos de nuestra sociedad. Susan, most welcome. I hear you had a transport problem. Good morning. Welcome. Susan, please have a seat right next to the minister. Nobody noticed your arrival. eh, Efectivamente, mi abuelo usaba decir que toda la vida es un problema de transporte. Yo soy ingeniero eléctrico nomás, pero siempre el problema es movernos. Entonces, el cómo poder transitar de manera sostenible. Y cuando hablamos de sostenible, no quiere decir solamente que nos vayamos a una agenda ambiental, ¿no es cierto? Que esto tiene que ser cero emisión y que no puede ser posible, sino que sostenible en la triple dimensión, en lo económico, en lo social, en lo ambiental. Y por lo tanto, el cómo nos movemos, y pensando además en un país largo y flaco como Chile, de que nos tenemos que mover a lo largo de Chile y lejos del mundo, como dicen algunos, nos tenemos que mover lejos también. Claramente la aviación y lo que podamos hacer en aviación es tremendamente fundamental. Y por lo tanto, nosotros como universidad, esta es la mesa que queremos ofrecer, el espacio de conversación, ya sea desde la mirada científica, desde la experiencia internacional, como también de las experiencias locales que vamos a escuchar hoy día, y por sobre todo, cómo podemos además desde las políticas públicas eh, poder avanzar tal como hemos sido tan exitosos en otras áreas como el transporte público, la transición a energías renovables. También podamos ser un ejemplo para la región de cómo un país pequeño, en términos relativos, su economía, pero que ha sido muy iluminador en esta transición energética, somos un champion climático, también podamos serlo en el ámbito del transporte. Así que, sin más, quiero dejarlos con ustedes a uno de los champions, precisamente en materia de transporte, desde que yo tengo memoria, hace 30 y tantos años que no conozco al ministro de Transporte, así que un privilegio y un regalo tenerlo aquí hoy día, ministro, de que comparta la visión desde su ministerio sobre los desafíos que tenemos en un transporte más sostenible, en particular en materia de la aviación. Así que muchas gracias por todo estar acá y muy bienvenido, ministro. Y pues pasamos al panel.
Yo soy alto, pero esto. Pero ahí estamos. Muy bien. Muy buenos días. Para mí, que vengo de la academia, y que esta es mi segunda pega, entre paréntesis, la de ser ministro, de los 26 años de profesor en la universidad en temas de transporte. Este es un espacio súper natural y agradezco muchísimo la invitación de la Universidad Adolfo Ibáñez a poder participar de este foro. El tema del transporte aéreo es un tema súper relevante para un país como el nuestro. Es que estamos en un rincón, ¿no es cierto? País esquina con vista al mar, decía alguna vez en una obra de teatro en los años 70. Lindo país esquina con vista al mar. Y agradezco el espacio que se brinda aquí en esta sala de clase y encuentro que el contexto de la sala de clase además es un contexto en que invita no solamente la reflexión, sino que la conversación. Es verdad que hay una persona que habla adelante y otros que más o menos que escuchan, pero en general la clase moderna es más de dialogar y conversar y poder levantar preguntas y poder ver cómo en forma conjunta uno puede ir abordando desafíos complejos. Y el desafío que nos convoca hoy día es enorme. Así que muy contento de este espacio, me encanta poder ver no solamente al sector público representado, sino que también evidentemente a la industria. Y este es un tema que tiene tantas aristas además, que estoy seguro que acá hay personas que seguramente miran el problema desde ópticas bien diferentes y complementarias. Y lo voy a ir viendo a medida que vaya en estas pequeñas palabras que traje. ¿Ya? Nuestro país, evidentemente, tiene la industria del transporte aéreo tiene un impacto muy relevante. Hoy día en nuestro país hace como 1,5 viajes en transporte aéreo per cápita, lo que parece como bastante elevado. Y hemos ido recuperando los niveles que teníamos pre-pandemia. Y la verdad que cuando uno pronostica para adelante, lo único que se puede imaginar esto va a seguir creciendo. Y tenemos muchas personas que empiezan a viajar en transporte aéreo por primera vez. Y eso, por supuesto, no solamente no tiene impactos para nuestro país en términos culturales, económicos, también creo yo que la industria del transporte aéreo ha sido clave en que como planeta nos sintamos como una gran humanidad. Cuando tenemos más personas que somos capaces de poder mirarnos y poder vernos y tocarnos de distintas partes en distintos rincones del planeta, pienso que eso hace que culturalmente también seamos más compatibles. La industria aérea ha sido un agente brutal, creo yo, en esta globalización, que ha tenido evidentemente efectos súper positivos. Hoy día, como contaba, ¿no es cierto?, estamos haciendo cada vez más viajes. Por supuesto que cuando uno mira la cantidad de viajes per cápita que hace cada persona, hay un sesgo hacia el sector de mayor ingreso, eso es evidente. Y la contraparte de esta mayor movilidad en transporte aéreo hoy día yo diría que son las emisiones. Y la pregunta es cómo estas mayores emisiones en un contexto de cambio climático enorme que hoy día es cada vez más evidente, más elocuente. Estuve la semana pasada en Washington y hablaba, preguntaban cómo el cambio climático se observa en el sistema de transporte. Y el año pasado fue tan claro para nosotros. Compramos los trenes más modernos de Sudamérica, los más rápidos, los que iban a andar a 160 kilómetros por hora, los que iban a ser motivo de orgullo del país. Lluvias en junio, lluvias en agosto, lluvias que no fueron tan distintas a las que uno tenía cuando era chico. No es como que uno diga, se cayó el cielo. No, fueron lluvias, importante, hubo una buena tormentita, buena, pero con una isotherma más alta. Con una isotherma más alta que hace que la nieve que está debajo, primero que nada, que la lluvia no cae como no queda como nieve, queda como lluvia. Y que arrastra también y derrite la nieve que ya tenía. Y entonces los caudales de los ríos sí que fueron históricos. Y sí que el caudal por el Biobío y por todos los ríos del sector del Maule, del Ñuble, están fuera de cualquier patrón. Y por supuesto colapsaron seis puentes. Y los trenes que teníamos preparados para poder encantar al país en materia de movilidad ferroviaria, resulta que ya están llegando a Talca, pero todavía no pueden llegar a Chillán. Denme un par de semanas y espero que lo vamos a poder lograr. Pero es el tipo de desafíos que nos trae el cambio climático, que a veces son como de rebote, ¿sí? Porque la isoterma es más alta, los caudales ahora ya no son los de antes. Entonces, es un problema muy importante el que estamos enfrentando y lo que la ciencia nos indica, y me imagino que en esta sala, cuando uno dice la ciencia nos indica, uno le toma respeto, es que esto va increciendo, ¿sí? Y que hoy día es cada vez más difícil poder apuntarle a esos 1,5 grados de aumento de temperatura, cada vez más difícil. Estamos hablando de 2. Y no me puedo imaginar lo que eso va a significar en términos de los cambios para las generaciones que vienen. Entonces, cuando uno está pensando en una que tiene un rol de gobernanza, es imposible no tomárselo con la mayor seriedad. En ese sentido, los objetivos de desarrollo sostenible creo que son un muy buen punto de partida, un muy buen marco para abordar un problema que tiene muchos ribetes, en los cuales este es uno y que nos permite también relacionarnos con otros ámbitos de desafíos para nuestra sociedad que son importantes. Importante decir que nuestro país ha tomado un firme compromiso con la descarbonización. Hemos tomado decisiones bien audaces, queremos ser carbono neutrales al 2050, y cuando uno mira los distintos sectores de nuestra actividad, el transporte aparece como uno de los más difíciles de poder reducir. O sea, la generación eléctrica, bien. El transporte, mal, pero mal. O sea, no logramos bajar las emisiones de carbono del transporte. Y es que, claro, nuestros viajes están muy basados en movimientos basados en el motor de combustión interna, que genera emisiones importantes, a pesar de los avances tecnológicos que en la industria aérea han sido importantes para reducir y mejorar la eficiencia de nuestros motores y que en el fondo nos podamos mover aviones más livianos, con menos energía. Sin embargo, en transporte carretero también, todavía tenemos una gran cantidad de emisiones y eso es súper preocupante. Es como si no estuviésemos escuchando. En fin, entonces es complejo, yo encuentro que es grave. Y nosotros hemos puesto entonces este compromiso de ser carbono neutrales para 2050. Tenemos distintos ámbitos de compromiso y en el caso, por ejemplo, de la movilidad terrestre, decimos, mira, de aquí al 2035, que está aquí a la vuelta de la esquina, todos los vehículos que se vendan en el país tienen que ser cero emisión, todos. Yo creo que eso excluye a los aviones, pero los vehículos, estamos hablando de transporte caminero. ¿Ah? Me imagino que excluye, no lo había pensado. Ya, siempre pensé en autos, camiones, buses, 2035, y eso significa, ahora estamos lejos, nosotros vendemos como menos del 1%. Ahora, China vende más del 37%, lo que habla de que no es una locura, porque uno podría decir, ¿quién en el mundo? Bueno, China. Hay países que ya están avanzando bastante más rápido, y por lo tanto uno podría decir, hay un futuro posible. Tal vez tenemos que buscar la forma de acelerarlo. ¿Sí? Y para el 2040 queremos ya todos los buses del país sean eléctricos, que para que todos sean eléctricos mucho antes tienes que empezar a comprar solo buses eléctricos, porque si compras un bus diésel el 2039, el 2040 está operando, obviamente. ¿Sí? Eso es parte de los desafíos que nos hemos ido poniendo. Y hemos ido adoptando también en materia de transporte aéreo propuestas por la Organización de Aviación Civil Internacional, la OACI, que abarcan aspectos tecnológicos, operacionales, de mercado. Y es interesante eso, ¿ah? Hay temas de operación, de tecnología, y a mí me parece muy importante también de mercado. Es decir, aquí hay oportunidad también para poder ver cómo los incentivos económicos se disponen y internacionales para poder determinar dónde y cuáles son los lugares en los cuales tenemos que dar los saltos que son más costo efectivos para un sistema de transporte aéreo que no necesariamente se tiene que fragmentar país por país. Bueno, y además, ¿no es cierto?, la promoción de lo que hoy día nos convoca, que son los combustibles de aviación sostenible. Respecto a esta última medida, quisiera mencionar que el año pasado los países miembros de la OACI establecieron una meta global de descarbonización de un 5% mediante el uso de SAF para el 2030, que no, está bien cerca. Y nosotros como país, si bien estamos interesados en avanzar, todavía estamos en una etapa bastante prematura. Estamos comprometidos a aportar a esta meta global, trabajando activamente para aumentar la producción y el uso de SAF en nuestra industria aeronáutica. La promoción de los SAF, entendemos, y hemos venido trabajando junto con Martín Mackenna, secretario de la Junta de Aeronáutica Civil, en cómo podemos llevar adelante esta política y esta industria hacia la descarbonización. A mí me interesa mucho el tema ambiental y climático, y entiendo que para la industria aérea es más difícil. Hemos tenido buenas conversaciones y estamos decididos en avanzar en este sentido. Y aquí el programa, por ejemplo, Vuelo Limpio, que es gestionado por la Agencia de Sostenibilidad Energética y la Junta de Aeronáutica Civil del Ministerio, han ejercido un papel fundamental al reunir diversos actores de la industria para desarrollar una hoja de ruta que permita la producción de SAF a nivel nacional. O sea, hay una hoja de ruta y la idea es cómo llegamos a poder, hoy día no producimos SAF, cómo llegamos a producir SAF y cómo generamos acciones que nos permitan llegar a esa carbono neutralidad que nos interesa. Esta iniciativa, coordinada con el apoyo del BID, marca el inicio de una serie de acciones que nos van a ir acercando cada vez más al objetivo de descarbonizar la aviación. Y aquí un par de temas que yo creo que van a ser interesantes para la audiencia. Estamos muy contentos de poder anunciar la hoja de ruta de los SAF, que va a anunciarse y se va a lanzar a principios de abril. Creo que debería marcar un punto de partida en este diálogo político, en este diálogo público, privado, académico con la industria respecto de una meta en la cual queremos mostrar un firme compromiso. Estamos también comprometidos, ¿no es cierto?, que el 2050 el 50% de los combustibles sean SAF, 2050, la mitad. Y queremos también que en Chile se produzca el primer litro de combustible SAF al 2030. Nos parece que son metas que son ambiciosas, pero son atendibles y son factibles. Y eso es parte de lo que vamos a estar abordando. El desarrollo de estos combustibles no solo representa un paso crucial hacia la sostenibilidad del transporte aéreo, sino que también es una oportunidad para fortalecer esa colaboración público-privada y promover la innovación en la industria. Como ministerio nos comprometemos a seguir trabajando, ¿no?, en este ámbito con determinación y prioridad para que esta hoja de ruta se implemente de acuerdo a lo que está descrito, y que eso se realice desde el ministerio en estrecha colaboración con cada uno de los actores involucrados. Es decir, en este sentido, transmitir nuestro interés de poder generar todos los lazos posibles, porque entendemos que esto solo se construye juntos. Ningún actor lo va a poder desarrollar solo. Se necesita el sector privado, se necesita el sector público, y estoy seguro que la academia puede hacer grandes contribuciones. Y es que la academia puede desarrollar un papel fundamental en esta hoja de ruta, que tiene muchas dimensiones, ¿eh? Está la dimensión evidentemente económica, incentivos asociados de cómo logramos acelerar, incentivos que estén bien alineados con lo que uno busca. Por supuesto que hay desafíos tecnológicos. Estoy seguro que aquí debe haber la ingeniería mecánica, la ingeniería, ¿no es cierto?, la biotecnología, hay procesos biológicos súper interesantes. También está el tema de relaciones internacionales, creo yo, de cómo logramos generar los incentivos para que los SAF se vayan desarrollando en aquellos lugares en que es más costo efectivo. Tiene poco sentido que si yo tengo viajes de A a B y en A cuesta un 10% la producción de SAF que en B, que yo a los dos le exija producir la misma cantidad. Quizás tiene mucho más sentido decir, oye, que tu avión cuando vuela en el sentido para acá se haga cargo del SAF que yo tengo que producir, y tal vez yo te subsidio ese esfuerzo. Eso es mucho más eficiente, pero esto exige también un diálogo internacional que es, yo creo que clave para que esto pueda tener éxito. Me parece un ámbito interesante de poder avanzar. Obviamente tiene asociado también temas de procesos industriales. Acá parte clave, me parece a mí, es cómo podemos ocupar parte de los desechos de la industria, ¿no es cierto?, los residuos también para poder ocuparlos, pero también quizás generar combustibles SAF, ¿cierto? Sustentable a través de procesos específicamente con ese propósito. Esto va a requerir además una capacitación importante de profesionales y creo que la academia en ese sentido parece como el lugar donde tenemos que generar programas que lo permitan, probablemente mucho también asociado a investigación, posgrado y tesis de investigación. Tenemos que seguir en esta línea de colaboración, ese es me parece que es el marco. Estas iniciativas, estas plataformas no pueden ser pasajeras, tienen que ser también flexibles para ir adaptándose a los desafíos que van surgiendo, que son de un planeta cada vez más dinámico. Creo que tienen que ser capaces de perpetuarse en el tiempo. La continuidad de estos esfuerzos va a permitir difundir estos proyectos y conocimientos que van a ser esenciales para la sostenibilidad de los distintos sectores y enfrentar los desafíos medioambientales que tenemos como sociedad. Quisiera finalmente terminar reafirmando el compromiso como gobierno de promover un transporte aéreo más sostenible y contribuir de esa manera al bienestar del país y del planeta en su conjunto. Así que muchas gracias por tenerme acá, tener la paciencia de escuchar estas palabras. Que estén bien.
Agradecemos las palabras del ministro. Ahora daremos paso a la charla magistral dictada por la experta Susan Van Dijk. Así que, Susan, we now welcome you to the stage for your presentation.
Thank you so much for inviting me to speak here today, and I apologize for being so late. It was like a comedy of errors with the taxi, so I'm just happy to be here. It would have been quite a disaster if I took 20 hours to fly here only to miss my talk. So, although I don't understand Spanish, Claudio translated some for me, and it's very exciting to hear that Chile is so progressive about climate change and also excited about developing of SAF here. So I'm hoping to just explain to you a little bit, give you some depth of information about sustainable aviation fuels and some of the key issues. So just to give you some background about some of the work that I've been doing, I worked as a task coordinator for IEA Bioenergy Task 39. And since then, 2014, I've been involved in writing multiple reports for IEA Bioenergy. All these reports are available from their website. And initially, we had reports on drop-in biofuels, and then we expanded into co-processing for production of biofuels, and also got involved in various projects around SAF or biojet fuels, as we called it at the time. So I've just finished a second report on SAF biojet that I completed a few weeks ago. It's not available yet, but it should be publicly available. So other work that I've been doing, a lot of it with Professor Jack Sadler, in whose research group I am still involved on a part-time basis. And so we did some reports for the International Renewable Energy Agency. We've done work with Transport Canada here. This report, we've done Boeing-funded projects since 2015. Specifically, that one looked at a project for fast pyrolysis, hydrothermal liquefaction for SAF production. And then we've been doing a lot of reports with Professor Sadler, his company, consulting company, Torag Energy. We've been doing work for the federal government, reports on sustainable aviation fuels and co-processing. I'm also currently working with Deloitte, doing yet another report. It seems that they just keep doing a new report every few years, but nothing much happens. So we all know about the climate impact of aviation, and this graph just illustrates the expected increase in emissions. So although it's only 2 to 3% of global emissions at the moment, it's the fastest growing mode of transportation, and it will just keep increasing in spite of the efficiencies that are introduced by aircraft manufacturers and engine manufacturers. So while the industry is committed to net zero, this is going to be a very challenging task, and many measures are required. And both IATA and ICAO have been looking at which measures and with different scenarios. And regardless of the scenario, SAF is going to have to be the biggest component by 2050. And here I'm just talking about CO2 emissions, but of course, there's the whole issue of non-CO2 climate impacts, which can be far greater than the CO2 impacts themselves. So when we look at this table here, for example, we say, well, there's development of electric aircraft, there's hydrogen, etc. But when we look at the distances that these flights will be, for the medium and long haul flights, there aren't really any other opportunities. Even where hydrogen might start playing a role, this is only really seen later on past 2035. And this graph also shows you that about 6.2% of the flights create almost 52% of all the emissions. So the area that has to be addressed from an international aviation perspective is the long distance flights, and there SAF is really the only option. And the reason why I want to emphasize this is because I'll get to the point that it's absolutely critical that this has to be developed, because we have no other options. So currently, we are only producing a very, very small amount, less than 1% of expected jet fuel demand. And in 2022, it was only 300 million liters. And it has been increasing. And for 2024, there are some projections that it will be about 1.8 billion liters. Maybe that could be a little bit optimistic, but it's still less than 1%. So this graph from IATA just illustrates that, you know, there's multiple reports telling us how much SAF they think we are going to need, and that for about 450 billion liters, that represents only about 70% of jet fuel demand. So because of the growth that is expected. So depending on which report you read, this can vary up to more than 600 billion liters. And, you know, a report such as the ICF report, part of the ATAC Waypoint 2050, said we'll need about 4,000 to 5,000 SAF facilities. Of course, that does depend on the volumes that will be produced. So the challenge that we have is absolutely enormous. And looking at the current commercial status, a lot of reports and so on will look at ASTM certification status. So there are currently 11 technology pathways approved under these two ASTM standards. But of all of those 11, only one is actually fully commercial, and that's the hydrotreated esters and fatty acids, a pathway called HEFA SPK. And if you look even at the Fischer-Tropsch, so this was approved in 2009, but what people don't realize is that was actually based on coal, SAF, jet fuel from coal. Sasol in South Africa actually submitted that application. And to this day, we don't really have a fully commercial Fischer-Tropsch production process based on biomass, and I'll show you why that is the reason. So people think that ASTM status equals commercial status, and that is not the case, because the ASTM approval does not mean that technology is commercial or that the fuel is even sustainable, because you can use these same pathways for any type of feedstock in terms of the chemistry, but it doesn't tell you anything about the sustainability. So a lot of these pathways have been there for a long time, and we haven't seen any commercial volumes of SAF being produced. So this is some data from Argus Media. I've looked, there's probably 5 to 10 different websites where you can look at new facilities, the status of SAF. Everyone's trying to predict how much we're going to have. So I've just taken this information from Argus Media from a couple of months ago, and it shows that there are 142 new facilities that have been announced with a total capacity of 33 billion liters per year. And there are many more announcements on a daily, weekly basis. But the first thing is we don't really know the volumes because SAF is just one product. So you can't take total capacity. So it's hard to actually clarify. Plus, SAF might not be the best product from a financial point of view. And I'll get to that point again. So most of these are just announcements, not final investment decisions, and expected completion is not clear. But to just give you a little breakdown of the types of technologies in terms of the number of announcements, you'll see most of them are still HEFA facilities. There's been a lot of announcements for power to liquids, alcohol to jet, Fischer-Tropsch, co-processing, and this is a distribution by region. Asia Pacific, as you can see, has mostly HEFA facilities planned, and that's because that's the feedstock that they have available. Most of the power to liquid facilities planned is in Europe, and that's partly because they don't really have a lot of feedstocks. But the other critical thing is the policy drivers, because the Refuel EU aviation mandate has a specific target for e-fuels, which will amount to about 600 million liters by 2030 that has to be blended. So there's a lot of pressure on companies to commercialize the power to liquids. And there you can see some of the volumes, but as I said, it's not really clear. And what you can see here is that by of all these facilities, HEFA will still be the bulk of the volumes. So if we look at these expected timelines, everybody's trying to sort of predict which technology is going to come in, how much we're going to have. But I think the one conclusion across the board is that by 2030, the vast majority of our SAF, probably at least 80 to 90%, will still come from the HEFA pathway. And because of the critical issue of sustainability, what will limit the development of the HEFA volumes after that is the limitations on the availability of waste fats and oils, used cooking oil, tallow, etc. It's sort of anticipated that there's probably only about 30 to 40 million tons of waste fats and oils available. So some of the reports say that HEFA will be limited to about 10%, but that's not quite accurate because there are possibilities for other feedstocks. The other thing is that there's a high expectation of how fast these technologies will become commercial. Sometimes there's a big announcement like United Airlines announcement that there's a big offtake agreement for 1 billion gallons with Alder Renewables. And that announcement was made before Alder had even had a pilot facility. So people start expecting that SAF to become available within a year or two. But what we have to realize is that to just progress across different technology readiness levels will take at least 2 to 3 years. And then building a few 100 million liter scale facility straight off is usually guaranteed to fail. You have to have sort of an intermediate scale facility, especially when it's a first of a kind technology. So if a company announces a first facility at 500 million liters per year, I kind of question the wisdom around that. Also, just the timeline from announcement to operation. probably about 4 to 5 years, even if this is a near commercial facility going for a first of kind scale, commercial scale, because there's all these different funding, permitting, construction, commissioning. Some of the gasification Fischer-Tropsch facilities that are currently under construction started 2020 already. They're only expecting completion 2026 or later. So these things take time, and we have to be realistic about it, because high expectations, I think, create a lot of pessimism when these things don't come about. The success rate, just a month ago, I heard an interesting presentation. So Washington State University is leading a research effort called Ascent, and there's about 40 universities involved. And they are also, Professor Michael Wilcott there is also very involved in ICAO, and I'll show you some of their work. But basically he was saying the success rate for announcements and actually having a facility for HEFA was about 65% success rate. Fischer-Tropsch 28%, and overall about 46%. And that's for technologies that have been under development. So the success rate might not be so good. So most of those facilities might not actually come about. That's basically what I'm saying. The other thing also is that offtake agreements are not a measure of commercial status and might have absolutely nothing to do with whether that facility is even going to be constructed. When we look at offtake agreements in the sector, ICAO has a database that shows offtake agreements, and that so far there's been over 50 billion liters in offtake agreements, even though some of these facilities or technologies are only at commercial scale. And you can see there some of the information by fuel producer. There's also a lot of airports distributing SAF, and it sounds very exciting, but it might just be extremely low volumes, but still it is quite exciting, all these developments. But, you know, the offtake agreements are mainly used by companies to get investment. So if they can sign an offtake agreement for 20 years, it's sort of some security for investors to put their money in there. But the reality is that we know nothing about the actual terms of the offtake agreement, and usually it would be, we'll buy your fuel if it's competitive with jet fuel. They're not going to, an airline is not going to commit to a specific price or say, we'll pay whatever you charge us. That's not going to happen. So the reality is that SAF development faces significant challenges. There's a very low availability of SAF, even though we do see technology scale up, it's still very, very slow. And people often ask me, which technology should we pick? Well, from a perspective of the industry, we need all the technologies to become commercial. But the problem is that the high production cost and large price difference with conventional jet fuels is a huge, huge barrier. There's also limited investment due to the high risk of new technologies. There's a very high cost of financing SAF fuel production infrastructure. And what's really critical is stable, long-term and widespread policy support. And until a few years ago, there was only one facility in the world producing some SAF, and that was in California. And that was the only place where the policies were favorable. So we also have a limited availability of cost-effective and sustainable SAF feedstocks. You see a lot of reports saying how much feedstock we have available, but if you don't take into account how much it costs, you know, that's not very realistic, and a lot of feedstocks might not be sustainable. There's also competition for resources and incentives with other sectors. So this is just a little graph from S&P Platts, just showing the change or the difference between jet fuel and SAF. So last year, SAF was selling at one point for over $3,000 per metric ton. Currently, it's actually quite low, but on average, it's about 3 to 4 times more expensive. And this is for a commercial, fully commercial technology. This is probably the cheapest SAF that you will find. When we start looking at other technologies, I'll show you some of the expected production costs. So this is work done by Washington State University, and it was actually used for the ICAO SAF rules of thumb, but you can access all their techno-economic analyses, Excel spreadsheets online. It's freely available. So I just try to summarize some of that information. So the orange is the pioneer facility. So that would be a first of kind facility. And that is expected to have a much higher cost of production, at least 50% higher, but it's often also underestimated. And then as you get multiple facilities for the same technology, you can get some economies of scale and improvements, optimization, which moves you to the nth facility, which is the blue or purple. So this is minimum selling price, which is basically a break-even price. So when you set the net present value to zero. So this is before they've actually added any profits or anything. So the first thing that you see is that there's no pioneer for HEFA because it's already fully commercial. Then if you look at some of these others, while the pioneer for gasification is very high, it does come down substantially. There's no pioneer data for power to liquids, but as you can see, even at an nth scale, the minimum selling price is much higher than any of the other technologies. So this just gives you some indication. Obviously, this is for US circumstances, but for developing areas, there was some work done for Africa, which said because of the higher interest rates and stuff, you could expect this to be even 30% higher. There's also the same techno-economic assessments also give you an indication of the capital cost of new facilities. And you see this incredibly high capital costs for gasification facilities. Some of the companies like DG Fuels and Velocis are constructing these facilities in the US, and their estimated capex is over $4 billion. So basically, if there's one take-home message, without policy, SAF development will be limited. What we need is policy that is stable over a long period of time, preferably for the duration of the investment. We need to bridge the price gap because it's a chicken and egg situation. Airlines say we want to reduce our climate impact, but if we buy very expensive SAF, we won't be able to compete with others. So, yeah, as far as investments go, we need to address high capital costs. It's very difficult to get investment. So loan guarantees or capital grants, for example, there needs to be a de-risking of investment to allow commercial scale up. We need to increase production and availability with our policy, address competition with road transport, and ensure sustainability and substantial emission reductions. So, as I said, about 2018, 2019, only the World Energy Facility in California produced any SAF. And now we've got 142 companies that have been announced. And the critical difference is really policy, because the US and EU has been driving the development of SAF through policies in the European Union, the Refuel EU aviation volumetric mandates. This creates a structural demand with a dedicated sub-target for power to liquids. And then, of course, the Inflation Reduction Act with two components, a blender's tax credit and a producer tax credit. at very, very substantial volumes. So the Refuel EU mandate it has very, very ambitious targets, up to 70% by 2050, with a very high target for synthetic aviation fuels or e-fuels. And as I said, the Inflation Reduction Act. Then we've also got the development of a lot of low carbon fuel standards. California has had one for a long time. Then Oregon, Washington State, British Columbia has had one for probably 10, 14 years as well. Canada introduced one last year. More recently, New Mexico, just a couple of weeks ago, New Mexico approved a low carbon fuel standard as well. But those low carbon fuel standards have not included jet fuel as an obligated fuel. California for many years had an opt-in, so you could earn credits without actually having to an obligated reduction in carbon intensity. But recently, British Columbia has really pioneered their low carbon fuel standard from January 2024, now includes jet fuel. With first 2 years, there's no obligation to reduce the carbon intensity. Then there's an obligation starting, and then from 2028, it also includes a mandate, I think of 1%. So they are really the first to do this. Then other types of SAF-specific policies, we've seen in Illinois, Washington State, Minnesota, there's been SAF-specific credits, very substantial, like $1.50 per gallon of SAF produced, and for 10 years. So it gives a lot of security to investors, no problem. And then other countries, Japan has indicated that they want a 10% target by 2030. There's a lot of this kind of talk of ambitions, or that what they want to see, but some of it is not yet in the legislation. Then we also see voluntary actions really that have been driving SAF demand, like buyers alliances, SABA, where companies come together to buy SAF to reduce their scope 3 emissions from business travel. So next, I just want to go through some of the technologies. This is also the type of work that you'll see in the IEA reports that I've written, just giving you a snapshot. So the HEFA SPK is a simple process where you have a hydrotreatment to remove oxygen, and then you have a hydrocracking or hydroisomerization to produce multiple fractions. But although until recently there was about 7 billion liters capacity for HEFA facilities, all of them made renewable diesel, and it was only 1 or 2 facilities that actually made SAF. And I'll explain to you why that is. And the facilities that have been announced for renewable diesel production, the volumes probably go to 30 billion liters, and there are so many facilities planned. But again, the question is, are they going to produce SAF or not? Because they don't have to, and I'll explain to you why. And to produce SAF becomes more expensive because it requires more processing, and generally it would reduce your liquid fraction total product by about 10%. So it's not financially beneficial for a HEFA facility to produce SAF unless there are policies to drive that. So what we are seeing is that there's significant expansion, and a lot of petroleum refineries are converting, repurposing refineries because it's obviously cheaper. There's a lot of co-processing, inserting lipids into an existing petroleum refinery. I'll talk about that. And this is fully commercial and quite optimized, everything. The key challenge is really feedstock cost, which is already higher than the cost of conventional jet fuel. Feedstock cost is also about 80% of the operational cost. As I said, availability is going to become a problem, especially where you want a very low carbon intensity SAF, and sustainability. So there are a lot of crop-based oils, but of course the sustainability is in question. So we see a lot of potential and opportunities for this technology because it's already commercial, there's substantial global capacity, and unlike other types of feedstocks, oils and fats have high energy density. It only contains about 11% oxygen, so you can transport it globally. It's a commodity, there are supply chains in place, and it's economical to transport. If you can get the policy right to shift to a bigger SAF fraction, then you can immediately produce very, very significant billions of liters of SAF. And co-processing is also a huge opportunity. As I said, the high feedstock cost is a problem. Waste feedstocks used to be cheap. Now it's, I've seen in some cases that in Europe, used cooking oil can become more expensive than rapeseed oil. There's also limited availability. There's a lot of competition with biodiesel and renewable diesel. Other low carbon intensity feedstocks that a lot of people talk about, cover crops, camelina carinata, jatropha, dedicated crops, algae. This has been discussed for years and years and years, but those technologies are not commercial or at scale. And that is one of the things that would have to be targeted. So for example, in the US, they have specific goals under the SAF Grant Challenge to actually target the expansion of commercial planting of these. Another challenge with the low quality waste feedstocks is that it requires more pretreatment. I talk a lot about that in the report that I've written. And another interesting challenge here, what's been happening in Europe is because they do not allow crop-based oils for SAF production, they've been importing huge amounts of used cooking oil from places like China. It has just absolutely exploded, but there's a lot of suspected fraud going on because the used cooking oil is coming from areas which, you know, you can sort of calculate per person how much used cooking oil should be produced, and it's not realistic. So basically contaminating palm oil or some other oil to actually create used cooking oil. So this is quite a technical aspect, but I just want to briefly mention it. And if you have questions later. So this is just to explain, I said the competition with road transportation, specifically when it comes to the HEFA pathway. So any refinery has a distillation process to separate different products into fractions, but the refinery chooses those fractions based on boiling point year. And we have gasoline in a specific range for boiling point and carbon number. We have jet fuel and we have diesel fuel. But because those overlap, a refinery may choose to not make jet fuel and only make gasoline and diesel. And the same thing applies when it comes to HEFA, the renewable diesel refinery. This is the average chain length of a fatty acid, like in vegetable oils, which falls in the diesel range. So if they just put it through a hydrotreater, they can produce diesel, renewable diesel, and sell it all as diesel. If you now want to produce SAF, there's about 15% of your product will be in the jet range here between C8 and C16, but then you would need to put in a distillation column to separate it out, which is more expensive. Plus, jet fuel has very high standards for freeze point, so now you have to put isomerization in. If you want to make a bigger fraction than 15% SAF, now you have to do cracking. Cracking produces more lower value gases, and therefore you lose yield of liquid. So that's basically the rationale around why policy is needed to address that competition. So the alcohol to jet pathway can go through many different routes. You can take sugars or starches, ferment it to make ethanol. You can take biomass to make cellulosic ethanol, or you can take CO2 gases, ferment it like the LanzaTech process, and you can produce multiple types of alcohols. So Gevo produced isobutanol and obtained ASTM approval for that. LanzaTech got approval for ethanol, and LanzaJet is now commercializing this relatively simple process. You can make naphtha or jet and diesel depending on your process. There are lots of easy feedstocks, but these have sustainability concerns, and a lot of focus is on cellulosic ethanol, but this technology is not commercial, and although ethanol from syngas attracts a lot of attention, we don't really know much about the yields or the costs. So the opportunity is that we can take alcohols that are already there. Methanol is in the pipeline for methanol to jet production. We've had our first commercial facility opening in January, the LanzaJet facility, and there's a relatively low capex. It doesn't matter where the alcohols come from. The alcohol to jet process is the same. There is access to conventional ethanol, which can achieve low carbon intensity. Sugarcane definitely has a very low carbon intensity, and the LanzaJet facility is actually using sugarcane ethanol and can achieve more than a 50% reduction. And they can also produce a large SAF fraction. LanzaJet claims 90%. There are challenges, of course, commercializing cellulosic ethanol and addressing this issue of carbon intensity and whether crops can be used. And there's been a whole debate in the US around this. Then I just have a few minutes left, so I have to speed up. The gasification and Fischer-Tropsch. So we have our first commercial facility, Fulcrum, but they are not upgrading their own fuels. They're sending the Fischer-Tropsch liquids to the Marathon Petroleum Refinery for co-processing. As I said, very high capital cost, and syngas cleanup is a challenge, not because it can't be solved, but because it's very expensive and difficult. But companies like the Red Rock Biofuels have failed. Velocys just recently had to be bailed out. The Enerchem facility in Edmonton, Alberta, they were making methanol from gasification of municipal solid waste. They just closed down their demo facility, and Fulcrum Bioenergy has been having some financial difficulties. So although it can have very low carbon intensity, and there are large low carbon intensity feedstocks available, this is a very challenging technology. It has a high capex, it's complicated, and each type of feedstock, you might have seen with the minimum selling price and the capex, if you use agricultural residues, it's a higher cost than for forest residues, than for municipal solid waste. And even though you produce a liquid, there are multiple products, and then you still have to put in place all the upgrading facilities. So the power to liquids, I know this is probably the most promising technology for Chile, so I'm sorry that I'm rushing through this, but basically the key issue, we can capture CO2. It's really the reverse water gas shift reaction to produce the syngas that is still at a lower technology readiness level. And as far as the co-electrolysis, the solid oxide electrolyzer, which can use CO2, that is still only at the pilot scale, and the integration of the process hasn't been proven. So there's a lot of commercialization of CO2, there's a lot of commercialization of the electrolysis, but integrating the whole process must still be proven. And this is still going to take some time. Most of the reports say that they don't really expect much power to liquid fuels by 2030, and even in the EU, where they need to get 600 million liters of SAF, that's going to be very challenging because the SAF percentage is probably only 40%. So it's got a lot of potential and opportunities. The challenges really is the cost is probably the biggest, and the fact that the electricity should be renewable, and the EU is putting in place a lot of very strict things that where your grid is not renewable, for example, then you cannot, claim that it's renewable, etc. So I'm not going to talk about this, but this is not ASTM approved, but you can use pyrolysis or hydrothermal liquefaction to produce SAF, but this is quite complex. I've been working on this for many years, and it has many, many challenges. And then lastly, just to talk about the potential for co-processing. Basically, it means taking a bio-based or renewable liquid intermediate and putting it in a refinery. There are different places where you can put it. For example, before the atmospheric or vacuum distillation, you can put it into the fluid catalytic cracker, the hydrotreater, hydrocracker, or you can just blend it in with your finished fuels. So there's a lot of co-processing efforts around the world taking place around this issue. And it has been ASTM approved for lipids, vegetable oils, and Fischer-Tropsch liquids, but you can only add 5% of your bio-based. And BP has been trying to push an ASTM committee to actually increase this because you can't really make much SAF. That 5% will probably be only 15% SAF, and you're losing the oxygen, so you only make a very small volume of SAF. But because of the Refuel EU mandate, these refineries in the EU have been making SAF through co-processing, except that they wanted to claim that all 5% was SAF, which it isn't, and new legislation is now making this more difficult. But throughout the world, co-processing has been used to make diesel at very high blends. So there are many feedstocks. I'm not going to go into that. And the whole issue of sustainability with crops, it's a lot about the induced land use change, which makes it very difficult to achieve low carbon intensity. And where you put policies in place, like the Refuel EU mandate, doesn't reward fuels that have lower carbon intensity than others. So if you have a 90% reduction in emissions versus a 50% emission reductions, there should be a different value attached to that emission reductions. And that's happening in US policies such as low carbon fuel standards, because you can earn more credits. But that's not the case in say, Europe. And that kind of low carbon fuel standard is a very good way to actually force emission reductions rather than just say, all SAF is the same, which it's not. So then just to conclude, I think SAF is critical to decarbonize aviation, but this is not just for airlines. This is for business travelers and everyone flying anywhere. It's not just the responsibility of the airline. We need large volumes of SAF, and although we have many feedstocks and many technology pathways, we're going to need all of them, not just one, because they can make use of different feedstocks in different areas. But without the right policies, the business case is not there. If we don't get the security to de-risk investment, we're not going to see these technologies becoming commercial, and we're not going to see airlines using it. A mandate like in the EU is going to force airlines to use the SAF and to pay for the SAF. So it kind of levels the playing field, and that's good, but it's still going to make it very, very expensive. So we need a combination of policies such as mandates, incentives, and not just one policy, different types of policies designed around what is needed within a specific region. So that's it. Any questions?
Hi, Professor. Thank you for your incredible explanation. I must say that I work in renewables, so I have some interest, of course, in my question. Obviously, I will ask about power to liquid. That is, it was clearly explained from your presentation that the cost seems to be high compared with the other technologies. I noted that numbers shows $4.4 per liter, right? I suppose there are many assumptions behind the number, and one of them is the cost of renewable energies. Can you please explain a little bit the assumptions behind that? Because this is extremely sensitive if we want to calculate power to liquid costs.
Yeah, I mean, I'm happy to also get your details, and I can email you the techno-economic analysis that was done. It's an illustration, but that is sort of what you see in all the reports. And yes, unlike the other technologies, it is unique in the sense that it has the potential for cost to reduce by 70%, because the biggest costs are the capex of the electrolyzers and the cost of renewable electricity. So bringing down the cost of the renewable electricity is probably the most critical issue. Yes.
Good morning. Thank you for this very interesting presentation. How realistic is this plan at the end of the day? I'd like to hear the scientific, because we hear a lot of the airlines, IATA, politicians, but from a pure scientific perspective, where do you see ourselves 25 years ahead of the goal to get 600 billion liters on the market? I've listened carefully, and I would say that you are somehow pessimistic on where we need to be right now to arrive to that goal, but maybe I'm wrong. And my second question would be, what do you think lacks from a pure legislative perspective? Because you don't seem to be fully convinced by Refuel EU on one hand. On the other, we have IRA. What would be the third path that you would see as a solution? Thank you.
Well, I think I wouldn't say I'm pessimistic. Rather, I would say I'm realistic. The expectations are very high, and people don't always understand the challenges. So the challenges are huge, and I don't know if I don't think we will get to that volume of SAF because the airlines don't want to talk about the elephant in the room, maybe that we have to fly less, for example, and that we should have more conferences online than to fly somewhere to talk about climate change. But be that as it may, you know, it will be very difficult. But it's not the science that is so much the issue. Scientists can solve problems. The problem is to make the business case work, because it's not just, oh, we'll produce it and you'll buy it, because it's not going to happen then. They will have limited volumes produced. So I am fully supportive of mandates. In fact, it's something that I've been arguing in Canada, and the airlines there don't want to hear anything of it. So, you know, you write these reports and you say there should be a mandate, because that's a clear way for me that you will force, you know, you will give that structural demand, you'll give security to the investors. And so I think British Columbia's new model, including the jet fuel, is probably the best way to do it, because it's a low carbon fuel standard. So that means that if you supply SAF into that market, you can earn credits. Now, British Columbia, it doesn't put a limit on the credits like California. And at the moment, those credits are almost $500 per ton of CO2. So they are going to just, all the SAF is going to go into British Columbia because of the financial, but it's not the government having to spend the money. It just is the market that is created for that. And airlines are complaining about it, but that's what's going to drive the production. And so that's the only way to do it. But in the Refuel EU, they have the mandate, but there's none of that financial support. You know, they're going to take money from the emissions trading scheme and give it to fund research and scale up and that kind of thing. But that doesn't really bridge that price gap. The IRA, everybody says the IRA is fantastic, but the blender's tax credit is already ending this year, and the producer tax credit is only 3 years. That is not enough security for an investor to say, okay, I'm going to get this credit now for a couple of years, but what happens after that? So the tax credits in Illinois, Minnesota, Washington State, those are for 10 years. So that kind of becomes more of a game changer. But basically, in the US, they are building all these facilities, but maybe they are relying on the fact that there's just going to be an extension of these credits. But, you know, that's going to be political as well. So the IRA sounds fantastic, and it's definitely companies in Canada have canceled plans for building facilities because of the IRA, but it maybe, you know, isn't that fantastic unless it's for a longer period of time. And I think that you need the mandate so that airlines won't have to compete just on that price.
Thank you, Susan. Pueden hacer más preguntas después. Ahora vamos a dar el paso al panel y al final del panel pueden seguir con las preguntas.
Thank you, Susan, for this. And now comes the conversation, so please come ahead. I have to leave for another conference on energy as well. So we have competing not only technologies, but also energy conferences. So así que pasen, por favor. And ¿podemos sacar una foto antes de eso, no? We maybe take a picture with the panel before we move on. Have a seat. ¿Dónde está Felipe? ¿Dónde? Siempre, ¿a dónde hacemos caso a ti? Where? Here? Felipe. Martín.
Okay, thank you, everyone. So we're going to start the panel. So the first thing that I'm going to do is I'm going to introduce our panel members. So please, all of our panel members, if they can take a seat. So I'm going to explain the way in which we're going to do the discussion. So first, I'm going to be asking a couple questions to some of the panelists, and then we're going to leave some time at the end of the session so that the audience also can ask a few questions. So without further ado, I wanted to introduce the panel members. So we have Judy Agüero in here. So Judy is industrial civil engineer from Federico Santa Maria Technical University, has more than 30 years of experience in the energy sector, both nationally and internationally. He has participated in various developments and commercial activities in countries such as Chile, Colombia, Peru, England, France, Italy, and Spain. Currently, Judith is the head of new business at ENUP, and in this position, he oversees the development of renewable and synthetic fuels. So let's give a welcome to Judith. So on the other side, we have Mayra. Mayra Keller has a degree in journalism from the Catholic University of Chile, and she holds a master's in communications and social development from the London School of Economics. She has experience in corporate affairs in multiple sectors and used to be the CEO of the Spanish Chamber of Commerce in Chile. Currently, she is vice president of ACHILA, director of the German Chamber of Commerce in Chile, and manager of corporate affairs and sustainability at Sky Airline. So let's give a welcome. So following the order, we have Martín Mackenna. So Martín has a business degree from the Catholic University of Chile and a Master's of Laws, LLM, in regulatory law from the same university. He has more than 10 years of experience in the transport sector and has worked for several companies. He is the Secretary General of the Civil Aeronautics Board of Chile. As the Civil Aeronautic Authority, he conducts high-level direction of civil aviation in Chile. He also represents the government before international civil aviation organisms. He has actively participated in representing Chile's position at important international events regarding air transport decarbonization, such as ICAO 41 Assembly, where a long-term global aspirational goal for aviation emissions was agreed upon, and the third conference on aviation alternative fuels. He has been leading the Vuelo Limpio program, promoting energy sustainability for aviation in Chile, which within other activities is currently developing the first SAF roadmap for Chile. So let's give a welcome to Martín. And finally, last but not least, we have Juan José Toa. So Juan José holds a degree in journalism, a master's and PhD in communications from the Autonomous University of Barcelona, as well as a diploma in sustainability from the University of Oxford. He has extensive experience in the design and implementation of communications, engagement, and sustainability strategies, managing the relationship of organizations with their environment. He has held various senior positions in the public and private sector, serving as an official for the Food and Agriculture Organization of the United Nations in Latin America and the Caribbean, head of communications and public affairs at Codelco, and head of corporate affairs for BHP South America. In 2019, he joined LATAM as director of corporate affairs and sustainability, reporting directly to the CEO, where he's responsible for the corporate public affairs, communications, and sustainability strategy. So let's give a welcome applause. Okay, so what I think I will do is I'll take a seat over here. Okay, yeah, thank you. So as Susan mentioned, it is very important to put some policies in place. It is critical indeed. And so I wanted to start with the aviation industry. So I'm going to start with Juan Jose, who's right here. So I wanted to start with this. So LATAM Airlines has funded, in collaboration with Airbus, a study which was conducted by MIT to determine the impacts of SAF development and decarbonization of the aviation industry in Latin America. Without sharing the entire study, what can you share in terms of challenges and opportunities for the region?
Okay, thank you very much. I feel very honored to be here. On my description, it wasn't that I taught in this university for 10 years, so I feel at home and I feel very pleasure to be here. And especially talking about this and bringing this important subject to a classroom where it has to be, where we all have to learn and share what we're doing and improving with the work we're doing. So thank you very much. We have as LATAM the challenge of being net zero by the year 2050. And if you ask me, I'm in charge of this. Do I know exactly how we're going to do this? And the answer is no, we don't know. So that's the first thing we have to point out. And because we don't have all the answers, we think that we have to go to places like MIT to try to find those answers and try to help the countries where we operate to have the best public policies to get to that place. So that's the first thing that we're working with MIT. What was the question that we did to MIT? Which is the pathway? Which is the best pathway to reach net zero in a sustainable way? What do we mean with a sustainable way? Being sustainable with the environment, that's the challenge that we have, and reducing emissions, but at the same time, being able to understand that this is a region that has an income that's very different from the incomes of developed countries, that has a geography that's extremely different, and that we have infrastructures and public services that are very different. When you're in the south of Chile and you have to have a complex operation, You don't have a hospital to get this operation. You have to come to you have to come to Santiago, and you have to fly to Santiago to do this. If you have higher taxes, higher tickets, what will happen is that you won't be able to do that. So we have to be sustainable with that people as well. So that's the main challenge. And I would say the last thing is, how can we take advantage of the conditions that we have in the region to make that happen? So we have great conditions, we have opportunities, and we have to take opportunity of that. So I would say very preliminary results of MIT saying, this is something that we have to do, and we have to do it fast, that we can do it, but it's extremely complex and expensive. So how can we do this? We need public policies, and I think you were very clear in that kind of public policy that we have to have in the region. All countries have a different pathway. I would say that those pathways change during the time. You have solutions that for today are good, but won't be good in the future. And the mix of all those solutions is what we can get. So in April, we'll have the final results. I think we'll have a result that from MIT saying this is something that we have to do, that will show us the path to do that, but that has extreme complexity, and that we need the help of public policies to be able to walk through this pathway.
Thank you so much, Juan Jose. So I wanted to take the attention over to you, Mayra, and I wanted to complement some of the remarks that we were just hearing. And so I wanted to ask you, how would you say government, regulators from the public domain, and industry should organize themselves to incorporate SAF and other policies to accelerate the carbon neutrality goal by 2050?
Okay, well, thank you very much. I'm going to read some of my notes. I think in this subject, I sound a lot smarter in Spanish, so English is a challenge. In Sky Airline, we are currently making a lot of changes towards the net zero goal. We are committed with this goal, as well as the industry. We know how complex and challenging it is. So I'm going to walk you through some of our strategy towards developing SAF, towards making SAF part of our portfolio of solutions, but also how we got there. It's a multiple area and very complex strategy. First, we have our fleet renewal. In Sky Airline, 100% of our fleet is operated by Airbus Neo technology. That has helped us to address most of our decarbonization strategy. In the last 10 years, we have accomplished not only a significant decarbonization process, but also it's part of our strategy. You know, SAF is one of the solutions, but there's also technology and as well as operational areas. So that is our first goal. The second part of our strategy is operational efficiency. And for people like me who are non-technical, this is basically how we know our aircraft, how well it's maintained, how well we fly it, and of course, how well we use data in order to make progresses. This involves a lot of areas and measures, and we have implemented a series of measures aimed at improving our fuel efficiency. That's our second most important goal. These initiatives have a lot of advantages, but also there's a point in which there's nothing else additional you can do. And then, of course, SAF is the alternative and the solution. What we see in Sky Airline is that SAF will be an alternative only if it becomes cost effective and if it is integrated with our efficiency business model. We are a low-cost airline, so efficiency, it's a crucial part of our business model. We see SAF as a complex pathway. We heard the minister previously saying he was wondering if the industry is really listening, or are we listening to the challenges? And I would say yes, we are listening, but we know that it's easy to say that by 2030, maybe the first liter of SAF will be produced in the region. But if we don't have the appropriate regulation, the appropriate incentives, and of course, we don't really understand the reality in Chile and in the region, that goal might be a little bit ambitious. And for airlines like Sky Airline, we will have to work on this big portfolio of solutions before SAF is really an alternative for us. So we want to get there. We really need this to make it possible. But we don't see that it's going to be anything soon. We know there is a pathway, la hoja de ruta, SAF. That's a first step, but we need to really, really make it work for our reality, which is not the European reality, which is not the American reality that Susan just went through. There's a lot of challenges, and we need that to work it out before we can really say we're listening. We're listening.
I see. Thank you so much, Mayra. So I wanted to go a little bit in depth into the roadmap, those milestones. And so I think, Martín, so I wanted you to tell us, what has the Civil Aeronautics Board have been working on lately regarding the decarbonization of air transport? And maybe you can tell us a little bit about opportunities and challenges that you guys have found while developing the 2050 SAF roadmap for Chile.
Thank you very much. Well, for this invitation, and sorry. First of all, I would say that we have been working very hard on how these decisions about SAF are being taken all around the world, because we have this global problem, so it has to be addressed globally, and different regulations and policies around the world should be aligned. That's why, in order to solve this common problem, that's why the role of the ICAO, for example, it's so important, and that's why we have been strongly working there. For example, when the LTAC long-term aspirational goal was settled back in 2022, or in the third conference on alternative fuels on 2023, where they set a goal for 5% emission reduction from the use of alternative fuels. And then locally, we have to work on how Chile commits and work on these global goals. And in this sense, we have been working with the Vuelo Limpio program, both from the Ministry of Energy and the Ministry of Transport. That's something that it's new for the aviation sector, that it's always had to solve their problems from the inside, and now they have to open to other industries such as energy, that always has been a very important supplier. But this is a common challenge that different sectors are addressing together. In that sense, we started at the end of 2022 working with this public-private task force to produce the first roadmap on SAF on Chile. And we are happy to announce that we have this final product ready to be launched on April 10th on the IATA event, Wings of Change, where we are also going to see the results of the MIT study that it's being carried out by LATAM and NERVA. So I think from 2022 to today, it has been a big improvement on having this topic to be discussed by the public opinion, by the academy, to be here today talking about SAF with new faces that are getting involved in this subject is an important landmark. And from the government, we have been working on that. And this roadmap is a first step, and also have some commitments that we made and other ministers made and the different sectors made. So with this roadmap, we will be able to start moving forward. For example, we will also have the first feasibility study to be done in Chile, feasibility study that is financed by the Netherlands because through a program by ICAO that is called SAF, where countries which are more developed in SAF research and availability help countries that are behind. So in that program, we got this financing to do the first SAF feasibility study that will be started by the middle of this year, and we hope to have the results by the end of this year. So there are things happening. There are studies from the private sector. There are companies that are starting to put SAF in their lineup, like HEAF in the Patagonia. So it's something that we are looking, that we know it's a very difficult goal to achieve net zero by 2050. We know there's not only one pathway, but we know because we have several studies about that, that SAF will play a significant role on that. How big, we will see, but it will be significant.
Thank you, Martin. So I wanted to, I think I will follow up a little bit on the last remark that you were saying. So you said that we still do not know, but definitely it's going to play a role. And so, Judith, I wanted to bring you into the conversation. So, which, in your opinion, is going to be the role of ENAP in the production of fuels with an increasingly lower carbon footprint?
Well, first of all, thank you for the invitation. After that, I would say that what Susan told us makes a lot of sense to us. And we've been seeing this, we've been preparing our decarbonization program, I would say last 2-3 years. And in this decarbonization program, we have 3 pillars. The first pillar is decarbonizing our existing facilities, our existing operations, in order to reduce CO2 in the production. After that, we have a second pillar. Is we already have a portfolio of products, fuels, obviously. And what we are doing is we're trying to find out how to have product with a lower footprint in terms of emissions. For that reason, we are working in 2 areas, mainly in renewable fuels, what we could do in renewable fuels. And after that, what we could do in synthetic fuels. Thinking in renewable fuels, there we find out there are 3 things we must take in care. First of all, the feedstock. It's a critical thing in the production of these renewable fuels. For that reason, we're talking with several companies in terms of finding out what are the feedstock that we could have. And after that, what kind of potential could we have in this industry? We think, for example, that the REP law is going to increase, or maybe it's going to make a better order in how logistics and how treatment of waste is going to be taken care. And so we're working a lot in the let's say the feedstock area. After that, we go through the technological area, and it's really a mess. There are a lot of alternatives. Well, we all know that we already know that there are 9 pathways, but there are a lot of other pathways that are being designed. And for that reason, we now are focused in main things that make sense to us in terms of what we have in installations. And as we are a refining company, so what we're doing is analyzing what kind of co-processing we can do. And after that, until say what percentage of co-processing we can have in our existing facilities. Because what we want to do is from now on to 2030 is to let's treat any kind of feedstock that we have to design. And after that, see how this fits in our present operation. And we will try to have a renewable fuel before 2030. At least that is our expectation. You said that they're not high quantities at the very beginning, and we're trying to really limit or keep expectations, and for that reason we have defined a plan in terms of let's say production that it's very, let's say, it's taking into account what is happening today in the world, and for that reason, and after that, taking into account that what we can do as a company. And the third thing that we're working on is off-takers. At the end, let's say for green hydrogen, for derivatives, for renewable fuels, if you don't have an off-taker, you can't do anything. And when are you going to have an off-taker? When you have policies and when you have regulations. And for that reason, we're working with several companies. And at the end, just as a summary, what we see is that no one is going to do this by itself, and we need in the 3 stages or the 3 areas in which we're working with several companies. For example, in renewable fuels, we're talking with several off-takers. We're talking with the technologists to see what kind of procedure or process we could fit. And on the side of the off-taker, for example, for synthetic fuels, we're working a lot with our friends of HIF in terms of seeing e-fuels and SAF. For that reason, at the end, what we're doing is working in all the areas that we can, trying to keep expectations of what is going to happen, and doing a lot of work in terms of technologies available.
Thank you so much. That was like a very detailed explanation. Thank you so much. So we're running out of time. And before I open the session for questions for the audience, I saw Juan Jose taking a lot of notes. And so I would like you guys to just give a final take-home message. I'm going to give the opportunity to everyone to give that message. It could be either, for example, something that you really want to say, or something that maybe one of your colleagues was saying, and then maybe you were not completely sure. Anything that you would like to be said as a take-home message. So please, Juan Jose, you can go on.
Great, thank you. I just wanted to share some thoughts on public policies on SAF and reaching net zero. I often get I got the question of, do you guys prefer the European model of mandates or the American model of subsidies? And I work in an airline, so I should say obviously subsidies. But if I ask Martin, do you guys have the money to subsidize SAF? Do you guys in ENAP, you're a public company, do you have the money to subsidize this? And actually it's
the money and the amount of money.
Yeah, and it's fair.
And we all know all the needs around in our country.
And it's not fair to say, you know, we prefer to build hospitals before paying for SAF.
Good question.
It's absolutely fair. On the other side, if I say, do our passengers have the money to pay for the SAF? I would definitely say some of them might have the money, but a lot of them don't have the money. So it's a tough question, because it's where do you put the cost of using SAF? And I think that's why I think in first place we have to take informed decisions, and not just saying, you know, let's copy the Europeans. Let's take informed and let's see what are the effects on our societies. We need the technical regulations, just so everyone understands here. If LATAM wanted to fly SAF today, in Chile, we wouldn't be able to fly it. So we don't have the technical regulations to use SAF. So how could we take SAF if we don't have the regulations to say, you know, you guys can fly that SAF? We have to find our own pathway with our own timing. It's fair that countries from the third world say, you know, we have to have a different timing. And maybe it's other countries who have to pay the initial cost of this transformation. It would be a fair question to ask the world if all countries should do it in the same. And the combination shouldn't be the same. Do you guys think that a country like Netherlands should have technically the same solution as a country like Brazil that has the Amazons, that has the extensity of it? Obviously, it's different answers to the same question. And as South Americans, we should find our own path that puts in value the conditions that we have. So for example, we have special conditions to produce SAF. We have special conditions to do offsetting and taking care of the best ecosystems in the world. And this industry has the chance of putting money in preserving those ecosystems that are extremely strategic for the future. And I think we should be open to all models. So we say we should produce SAF in Chile. I don't know, maybe not. Maybe we should have a better agreement with Brazil to buy the SAF. So I just say, I'm not proposing that. I'm saying we should be open to that. We should learn to collaborate. All of us were taught, we went to the university, and what we learned is how can we compete. In this one, we have to collaborate between companies that we compete, with governments, with other countries. None of us has the size of getting the solution to this. And a last thought about public policies. Today, the problem is not demand. Every liter of SAF produced in the world was bought by an airline, was purchased by an airline. The problem is, though, we don't have the SAF. All airlines are today trying to buy that last liter of SAF. So today the problem is, how can we produce more SAF? That will make better prices, and it will be available for airlines to purchase.
Thank you, Juan, for saying. So Susan, would you like to reply or give a...
Yeah, I can just make a couple of comments. It's interesting to hear what is happening from a perspective of Chile. Obviously, every country has to start with what do they have, what resources do they have, and Chile is definitely unique in that sense. But a thorough assessment of feedstocks from used cooking oil or waste from the forest sector, which I understand, potential for new kinds of crops, you know, in that can grow in these conditions, for example. So there has to be an assessment. The solution has to work for the country. And one of the biggest opportunities, obviously, is the renewable electricity, the incredible potential for solar. So e-fuels is an opportunity. And certainly, you know, one would have to carry out a proper techno-economic analysis of the conditions around Chile, because I can tell you that the Europeans are not going to be able to produce all the SAF that the e-SAF that they want. So it's an economic opportunity, not just, you know, if it's just about the airline decarbonizing, LATAM can buy SAF in the US and by book and claim, you know, reduce their emissions. But there's an opportunity for producing SAF here that is an economic opportunity as well. And many countries, you know, even when you look at the default carbon intensities, there isn't a one size fits all. There are obviously differences in different regions, and to capitalize on that. And as he says that it's a group effort. It's not just a simple market where you're going to go and buy it. All around the world for the last 10 years, there's been different initiatives that I've participated in, and it's about airports, it's about the airlines, it's about government, it's about fuel producers, it's about feedstock producers, and everybody coming together. And when you look at the policies, certainly I just highlighted a couple of the general policies, but there are a lot more options. In Singapore, the airport might have a fund that supports buying of SAF. Somebody has to pay for the blending, infrastructure. So there are lots of small ways in which it can be supported. And if you start with a very low blending volume, you can, it's not going to cost that much in terms of ticket prices. But if the funding to reduce that gap comes from different sources and thinking out of the box. I like mandates, but without the incentives to reduce the price, it's not really feasible. But at least then all the airlines will be affected in the same way. And of course, I love co-processing. I'm very supportive of co-processing. So there are lots of different opportunities. It's really just identifying them and finding a solution that will work for Chile to achieve these goals.
Thank you, Susan. So Mayra.
So, well, probably there are many things in which we don't agree with LATAM. But in this, I would say I agree 100% with what Jose just told us. And just as a summary of his ideas and just to make it more stronger, remarkable, I think SAF roadmap should not set goals before resolving which technology is most suitable for the Chilean reality. And this also has to consider exactly what technology is going to be available, which raw material are we going to use, at what cost, and of course, which incentives are we going to have as the industry and as producers. So I think we shouldn't set goals or regulation before we do have like a strong and clear scenario that we're dealing with. And I would say this is for us probably the most important thing to keep in mind. Thank you.
Thank you. I think we all agree, first of all, that we have a big challenge in front of us. We all agree we need to reach net zero by 2050. And I also agree, and I think it's commonly agreed also, that every country should support or get to this net zero ambition by its own pathway. So in Chile, we know we have a very geographic, specific geographic situation. We are far away from the rest of the world. We have a geography that where aviation, it's key to connect us inside the country domestically. So taking that into account, taking into account, for example, that we don't produce bio fuels for transport, for road transport now, we are in our specific point to start talking about SAF, but we have some good opportunities, mostly related to PTL. So do we have key advantages on producing PTL? Well, it seems we do. When will that be cost effective? We don't know yet, and I think that's some of the main things we need to start studying and discussing, and that will make us more clear how are we going to get to this net zero goal on 2050, and to our own goal of have a half of the fuel to be SAF by 2050 in Chile. Thank you very much.
Very short message. We feel that we're doing our part. We're doing let's say the technical analysis, the economics, the feedstock analysis. But nevertheless, we also think that we have done, or we have a huge step forward with Vuelo Limpio. I think it's a very important work done there. And what we're willing is to keep the pace on this work in terms of defining challenges and goals on this specific matter of SAF, taking into account that we have another important thing to look at, and it's the hard-to-abate sectors, where there's a lot of diesel, and we're working also on that in HBO.
Thank you so much. So I think we have some time for questions for the audience, maybe one or two.
Thank you very much. I'm very intrigued regarding technical requirements for propulsion systems. Is there any interchangeability of these different pathways, Susan, in the fuels? Propulsion systems of the aircraft, the engines, the turbines. Is it that really interchangeable?
Well, once a fuel is ASTM approved, it gets blended according to the standard, and then it is considered identical to conventional jet fuel. So in terms of the operability, it is identical. There's no difference at all. It has to meet all the requirements. So that's the safety issue. Obviously, that's why the blend is essentially drop-in. You don't have to make any changes whatsoever.
Yes, one question for colleagues of LATAM and Sky. Yes, so one question for colleagues of LATAM and Sky. I understand what you were saying, Juan Jose, on the need to have the technical requirements. But there's one thing that you've mentioned, and I'm quite curious to understand, is you've mentioned the money aspect. You basically the big topic is who pays. Is it the taxpayer or is it the consumer? And I think this is yet an unsolved answer from us in the room. I haven't heard, well, either taxpayer will have to pay more taxes to get the production ramp up, or the prices of the air tickets will need to go up. So how do you see it concretely? And I know that asking airlines is probably like asking the chicken if they're in favor of Christmas. But is this something that in your model you are taking into account, the fact that it's likely that prices will go up on the long run? Thank you.
That's exactly what we asked MIT, and what we hope. We won't get the answer like this is the answer to that question on April, but probably we'll be closer to that answer. And probably that answer doesn't have one, we have more than one conclusion and different conclusions over time. So just let me give you some examples. We fly to Europe, and when we fly to Europe, we'll get SAF in Europe because it will come with the fuel, with the jet fuel. So we'll be buying SAF. That's part of the solution. We have cargo clients, for example, that want to fly with SAF, and that's a completely different story, and that's a different, let's say, conversation. The conversation on producing SAF in the region, I would say that we have to take very informed decisions that allow us to have prices closer as possible to SAF. Why? Because if the client is the one who's going to pay part of that, or the airline, or the government, let's make that bill as small as possible. And I would say that that's the challenge today. And what we're seeing already in what the preliminary reports of MIT is that the difference of the prices are huge among different types of SAF in the region. Today, Brazil is the country in the region that has the best conditions by scale and by efficiencies to produce SAF coming from ethanol. And probably that's a first step that as a region we should start taking. When we think about Chile and we think about synthetic fuels, we're 15 years away from that. It's technologies that are not mature, and prices today are, let me say, 9 times from the fuel that we're paying today. Fuel that is about 35% of all the costs of an airline. So it's completely impossible to pay that price.
I think we have time for just one more question. So over there, maybe? Oh, over here. I don't know which one was first. Okay. If we can give him.
Hello, hello. First of all, I want to say thank you. And I hear a lot of the energy density of the sustainable fuels. So I want to know if it is a really problem or challenge, because I think specialists in long flights, I think that maybe it's a problem have a big volume of fuel.
Well, obviously the ASTM specification has a range for density, volumetric energy density that has to be met. And that's partly why there may be a limit on how much you can blend. So I don't foresee that as being a problem unless you want to fly with 100% HEFA, where the volumetric energy density is lower. Yeah. But otherwise, the ASTM safety specification, I suppose, is, there is a range and that they stick to that.
Thank you. So I think that we're wrapping up. So we do not have that much time. We wanted to first thank all of our panelists. I think it was a fantastic discussion. And thank the audience, of course. And I wanted to invite everyone to enjoy some coffee and some treats just outside. So thank you.
Oh, no, it's expensive, but